By the way, one of the colors isn't coming through, but that really is supposed to be the red planet, not the green planet. On my monitor, it's a nice bright orange. Okay. The spacecraft that we sent to Mars in 1997 is named the Mars Global Surveyor. It went into orbit around the red planet, and as soon as it lowered its altitude, it began surveying the entire planet Mars at low resolution, and also taking some high-resolution images whenever it could here and there of special features on the planet. Only a small percentage of the planet can be photographed at high resolution because there's just so much data in a high-resolution photograph, but each pixel in a high-resolution image corresponds to about the size of a person on the planet, about 1.5 meters. So high resolution really means a close-up of the surface, so you can see objects as small as a house or even smaller. The spacecraft went into orbit in 1997 and began returning its first pictures of the surface of Mars in 1998. And let's see. Okay, there we are. This is a sample of one of the low-resolution images seen by the Mars Global Surveyor spacecraft flying over the surface of Mars and taking images of the surface. In this low-resolution strip, which is a couple of 100 kilometers across, we see some craters that are perhaps the largest being about 50 kilometers in diameter. There are about 4 of them that are about 20 or more kilometers in diameter. And this one crater has, you can see it's a fairly flat-bottom crater with a steep wall, and that's the shadow of the crater wall, with the sun being over in this direction, casting its shadow. On the crater floor, most of it looks like the rest of the Martian terrain, but up in this area of the crater, we see a dark area, sort of like a stain on the floor of the crater. The white box that you see, I should mention before I say what the white box is, that we see similar stains in some of the other craters as well. We'd love to know what those are. Well, the white box shows where the Mars Global Surveyor spacecraft took a high-resolution strip image. These images are taken with the camera pointing down. It opens the shutter. It scans across the surface of Mars as the spacecraft flies by, taking a high-resolution view until the buffer is filled and then shuts off. So this is a typical strip image at high resolution. And it usually can only take one of those every orbit of the planet every 2 hours. Then it has to send it back to Earth and make room for more. So what we're going to do now is look at what the high-resolution image saw, because it started out over the plains of Mars here, went up to the edge of the wall of the crater, down the wall of the crater, started across the flat bottom of the crater, and then into the stained area before it ended. Now, this is the strip image, and this is just the top portion, the very top portion of the strip. And we see that it is relatively flat, featureless, desert sands. No craters to speak of. Well, one tiny one there in the middle. And there's not much to look at. If all of Mars were like this, it would be pretty much a disappointment as a planet. But we're scanning down the image now, the strip image, at high resolution. And we're coming closer to the edge of the wall of the crater where we see some debris ejecta from the crater. Here's part of the shadowed wall that's darker. Then we get down to the floor of the crater, which is brighter. And then we go across the floor of the crater and we come to the stained area. No one expected that. And what we see is that there seem to be some dune-like features in white and these black spots that are all over. And the black spots seem to like the sunlight, and they form a strikingly sharp borderline between whatever this is and the rest of the terrain. And we know from examining a lot of photos of these kinds of spots at a lot of different times of the Martian year, that the black spots grow larger in the spring, reach their peak in the summer, fade in the fall, and are sometimes almost invisible in the winter months of Mars. So what are these? They're certainly acting a lot like vegetation, but we see them in a variety of places, especially in polar regions. Here's one that shows the seasonal contrast, spots in midwinter, spots in the springtime where it almost seems as if there's been a melting going on in that area. Here's an area you can see how isolated this is from the rest of the terrain. Lots and lots of spots seen in a magnified view here. The same image. I guess you could call this a Martian pizza pie. This is a different place on Mars that has spots of a different character. Besides spots that change with the seasons, I should mention one other bit of data too. The Europeans have joined the fun of having an orbiter around Mars called Mars Express, and their camera is lower resolution, but it does take pictures in color. And their image of some of these spots shows that when they're at their largest, they are green in color. We see some of these things across the Martian surface too. We call them trails or tracks. What's curious about them is that they're rather straight for natural geological features, and they seem to have these grid-like patterns in the interior. And oddly enough, they seem to avoid cutting craters. They graze along the edge of craters many places, but they don't cut through craters. That's an odd thing for trails to do. But we've seen many other examples. Here's a low-resolution image showing that these trails or tracks can cross hundreds of kilometers across the surface. But for this one track here, we have a high-resolution view that's seen in this white box, and that's the view shown right here. And we couldn't even see at low resolution that there was a crater there, but here again, the trail just grazes the edge of the crater. It doesn't cut through it. And it looks very much like a trench that was carved. If these had been seen on Earth, we'd be tempted to say some large machinery drove through here. Here are some other tracks and trails, and we see now that there's an association between the black spot-like features and the things that look sort of vegetative and the tracks and trails. Well, that's a kind of human characteristic, isn't it? We have lots of roadways that we line with vegetation. But here's a case where one of the tracks and trails splits. Here's a case where there's a right-angle turn and then a veer to the left. And again, the vegetation follows. Here's a track or trail, again with more of these grid-like marks in it. And alongside, we'll call it the roadway, are things that look very fractal-like in appearance. They even seem to have branch structure to them. And they do, if you weren't told this was from Mars and were shown this picture, you'd say, well, okay, that's some kind of vegetation. Here's another example. Very spindly these things are at the right season of the year. And they all cast distinct shadows. These are not flat surface features on the surface. They have considerable height, tens of meters.